everyone. Today we're doing the very last section of this entire chapter, part 2. Again, here we're going to be in section 2, the very last part. After this, you should have all of your guided notes filled in, and we should have a test here shortly. So I just want to review a few things. First thing that I'd like to review is we talked about a mixture. And one thing that we talked about mixture, remember, this is a physical blend of two or more components. And these components can be elements. They can also be compounds. So you can have different compounds mixed together. You can have different elements mixed together as well. The key word here is physical, because what we're going to do now is we're going to get into how to separate mixtures. So separating mixtures. If you have a salad and it has an ingredient that you don't like, all you have to do is remove it with a fork, or you can remove it with your hands. I hate croutons on my salad, so I always remove them and give them to my mom. So that's one way you can separate a mixture, but not all mixtures are that easy to separate. Okay. So how can mixtures be separated? Well, there are a lot of different ways mixtures can be separated, but they are separated based on the differences in physical properties. And that's where them being physically combined comes into play. So you can use physical means to separate mixtures. So physical means to separate mixtures. Not chemical. Because remember, chemical separates compounds. So let's write that down. Chemical means separate compounds. So there's another big difference between those two. So to separate a mixture of olive oil and vinegar, all you have to do is decant or pour off the top layer. And that's because if you've ever seen oil and vinegar, the oil is going to flow on top of the vinegar. Another example of how to separate it is sometimes you might cool a mixture, and if they have different freezing points, one might turn solid, and then the other one's still liquid, and you can still pour off that liquid part. So pouring off the oil layer takes advantage to the fact that oil floats on water, or in other words, it takes into account the physical property density. Cooling until oil layer turns solid takes advantage of the difference in temperature at which oil and vinegar freeze. So again, that is another physical property of the freezing point. So both of these are physical property. Another example that we actually use, I taught my integrated science, but I also do this lab with my advanced chem kids, is filtration. Filtration is a process that separates a solid from a liquid in a heterogeneous mixture. So here's the key word. It has to be heterogeneous. Usually in filtration, you dissolve a part of the mixture into water. So usually you dissolve parts of mixture in water. Then what you do is you pass the solution through a filter. And the key part is big particles stay behind and small particles in the water flow through. So this is a good example of filtration. A coffee filter at the right can separate coffee grounds from the brewed coffee. What happens is usually a liquid coffee is brewed, so that's where they added water and dissolved those coffee grounds. And then what they did is the liquid is going to pass through, but those solid coffee grounds stay behind. So the solid big particles stay behind, and the small ones that are easy and small enough to go through the filter can go through to the bottom. So the physical property that filtration actually plays upon, that physical property is particle size, or how big is something. So the filter paper we use in laboratory is actually similar to coffee filters. You place the filter into a funnel, then you pour the mixture into the funnel. Solid particles, or big particles I like to say also, cannot pass through, and the rest can pass through, so because they're small. So brewed coffee is a mixture of ground coffee beans and water. What process is used to separate ground coffee beans from brewed coffee? Hopefully you've been paying attention. Let's see what you come up with. If you said filtration, you are correct. In fact, we're going to take this one step further. The coffee beans are going to stay behind on the filter. Stay. Because they're big, and the brewed coffee is going to pass right through because these particles are small. The next one that we're going to talk about is distillation. Distillation is something that we can't really do here at the school. It requires a lot of water, and in fact, I believe Miss Gertie did it and flooded downstairs. So we don't do distillation, but I do teach it because it is an important way to separate mixtures. So during a distillation, a liquid is boiled to produce a vapor and then condensed back into a liquid. So remember, condensed means gas to a liquid. And boiling is liquid to a gas. So essentially, in a distillation process, we have a liquid to a gas back to a liquid. So let's talk about the distillation process a little bit further. So tap water is a homogeneous mixture. If you actually look at tap water, you can't see the individual parts of it. So remember, homogeneous means looks the same throughout. Because these substances are dissolved in water. So one way to separate water from the components in tap water, like those ions and things, is through distillation. A distillation setup looks similar to such. You have basically a big, huge round bottom flask, and you're going to have a thermometer. You're going to have a heating source in order to turn it into a gas. This tube right here is called a condenser, and what it does is it has cold water running through it that helps cool down that gas to turn it back into a liquid. So let's talk about this process. As water in the distillation flask is heated, so right here, water vapor forms and goes up the flask. What it does is it passes into a glass tube in the condenser. The tube is surrounded by cold water, and that's going to cool the vapor back down to where it will turn back into a liquid. And that liquid water is collected in the second flask. So the solid substances that were dissolved in water actually remain back here at the distillation flask, and the reason is because their boiling points are much higher than water. So it takes a lot more heat to make those things boil, so they don't go up with the water. So if you were asking what physical property does distillation actually depend upon, distillation takes advantage of the physical property of boiling points. So which physical properties does filtration rely upon, and which does distillation rely on? So let's see if you can answer these, because we did talk about them. Let me know what you got. If you said filtration relies on the size, you are correct. Remember, big things stay behind, small things can filter through. Distillation is going to rely on boiling point because remember you have to turn it into a gas and then back from a gas to a liquid. So those are your boiling points. Now, before I end this, I do want to talk about a few other things so you're not quite done. Some things that I used in lab is you can use physical methods to separate things. So physical methods to separate things is you can use things like magnets if they're magnetic. You can use things like tweezers. You can use your own fingers to take something out. Any of those physical methods would also count. In fact, we actually did in freshman year a chromatography lab. So you can do things based on solubility is chromatography. Now these are just some more examples I just wanted to let you know about. But let me know if you have any questions, and that's the end of our lesson and the end of our entire chapter 2. Have a good day.